All right, so we are solving by completing the square. If you just completed the square and we weren't necessarily concerned about solving, that has applications in some of your conic sections, and we'll talk about exactly what conic sections are. A parabola is one of them, though, and I know you're very well versed in parabolas, or you should be. I mean, they're quadratics, which is what we're talking about here. But what we need to do, and this, again, originally I tried to change the font because this is hard to see. I don't know what it looks like on yours, but on mine, I guess on yours it kind of does look like an equal sign. But this right here on mine, because it gets blurry up here, looks like a minus sign, but this is equals. Okay? So equals, make sure that you can tell that that's what it is, and maybe you can, maybe you can't, I don't know. But basically what we're saying is we're going to have the two x terms on one side, we move c to the other side. Then we divide the entire equation by a, whatever your leading coefficient is, to eliminate it, of course, if a is greater than 1. Then we find b over 2 squared, right? And I'll remind you of what's happening, what that means when we get down here, and we add it to both sides. This creates a perfect square trinomial, which is one of our shortcuts for factoring if you recognize it. Most of the time, people don't recognize it, so you just end up factoring, and it's not that big of a deal. But basically, we're creating one so that we have something that we can solve. Because like on 20, if I tried to just solve it by factoring like we were doing the other day, you can't. It's not everything can be solved that way. Then we factor the trinomial and write our factors as x plus whatever squared, and it is actually b over 2, okay? And then we square root both sides and then solve both equations for x, write your answer as a solution set, and so forth. So here's what all this means. When we move this, we're going to make little blanks as we do this. So I'm going to subtract 91 from both sides. But my next step is going to be add something to both sides, so I'm going to leave myself some room. So we're going to do x squared plus 20x plus blank equals, and then when I move 91 over, that's going to be a negative 91 plus blank. Because remember, one of your basic rules of algebra is you have to keep the equations balanced. So whatever I add to one side, I have to add to the other, okay? How do we know what we add? What we add is what it just said over there. This is b. You take half of whatever this is, and you square it. So half of 20 is 10. When I square it, I get 100. And then I just add 100 to both sides. Okay. On this first one, I think I'm going to write an extra step just so that we can, well, no, I guess we don't need to. And we can combine this as we do it. But over here, this creates that perfect square trinomial. And the way you recognize a perfect square trinomial is that if you can take half of b and square it and get c, you have a perfect square trinomial. Well, basically, we just forced it to be that, right? So when I factor it, it's going to look like this. X plus whatever that half was, 10 squared. And if I do x plus 10 squared, that's what I get is the left side right there. And then that is equal to negative 91 plus 100, which is 9. So now both sides are perfect squares. They won't always both be perfect squares, but it is in this case. So now I can solve it by taking the square root of both sides. So when I go in here and I take the square root of both sides, I get, well, the square root of this thing is just going to be x plus 10, and that equals plus or minus the square root of 9, which is 3. Then I set up two little equations, because I'm going to have x plus 10 equals 3, and x plus 10 equals negative 3. So then when I subtract 10 from both sides here, I'm going to get x equals negative 7. And here I will get x equals negative 13. X equals negative 13 and negative 7. What questions do you have? Any questions about where anything came from? Okay. Now, on the Delta Math assignment, one of the things that I put in there, I had a bunch of options. I may or may not have put this one in there, but one of them just asks about the constant term. Like if I give you this setup, like what I have in dark pink here, that you just have to be able to look at that and tell me 100 is going to be what's added to both sides. Another thing I have in there is that it gives you whatever we're starting with, but instead of actually solving it, it's just asking you to get to that point before the square roots. Okay, so that's what it means when you get there. I think it should kind of be obvious. All right, 21. Is this already in the form I kind of want it in? Right? I got my x terms on one side, the constant on the other side. Oh, and somebody made the mention of the constant kept coming up. Was that somebody in here? On the SAT, the constant. Okay, so a little vocabulary here. The numbers in front of the variables, those are your coefficients. This is just a constant because it doesn't change. So your variable is x because it varies, depends on what I substitute in. But if I have x plus 5, x is the variable, 5 is the constant because 5 is not going to change. Does that make sense? That's the basic definition of constant, but there's more to it, I'm sure. I know there is, but we'll get to the rest of that, but just throwing that part out there. So here I'm going to have x squared minus 4x plus blank equals 48 plus blank. So what do you think we're going to be adding to both sides? We take half of b. What is b? -4. What's half of -4? -2. When you square it, what do you get? 4. So that's what gets added to both sides. 4 is one of those numbers, that kind of can throw you off because 2 plus 2 is 4, 2 times 2 is 4, 2 to the second is 4. But I want you to notice in these two examples that we did right here, one of them, the b was positive. Yes. Okay, yes, thank you. As soon as possible, but let's finish the lesson first. All right. Either way, whether b is positive or negative, you're still adding something to both sides because when you square it, it's positive. So you're always adding to both sides. You're not going to ever, it's not ever going to be subtraction. So then on this side, this becomes x. Now, what goes in between the two numbers is dependent on this. Since this was a positive 20, half of a positive 20 is a positive 10. Half of a -4 is a -2. Okay, so that's where you have to pay attention to the signs. And then that is equal to what? Equal to 52. 52, not a perfect square. But my next step, so again, this is at one point, and I think it has the little, there's a skeleton there. It's asking you just, what does this look like before it's asking you to solve. Then we're going to take the square root of both sides. So that means I get x minus 2 equals plus or minus the square root of 52. So you might want to go off to the side to do square root of 52. What are two numbers that multiply to give me 52? It's even, so it'll be 2 and 26. Good. 2 is a prime number. Then this would be 2 and 13, and that's a prime number. Right. Then once my tree is done, I start to look for pairs. And so what I'm going to do here, let's see, we'll just rewrite this as x minus 2 equals plus or minus. Well, these two 2's come out as a 2. This guy stays alone in the house. Okay. And then I'm kind of like here where I was on this one. I can really just now jump to this because I will have x equals, and then when I add the 2 over there, that's going to be a positive 2 plus or minus 2 square roots of 13. And you can't simplify that anymore because it has a square root on it. What questions do you have? Anything? Does this sound familiar at least? Yes? No? Maybe? Yes? Okay. For some of you, it might have been a couple. Do you do it again in Algebra 3? Where are my Algebra 3 people? Did y'all do this in Algebra 3? Yes? Okay. So some of you did it in Algebra 2 and Algebra 3. Some of you only did it in Algebra 2. Just depends on, but you definitely should have done it in Algebra 2. I don't exactly know what else in Algebra 3. All right, so let's go to the next one. I had to do this because it didn't fit on one page. All right. Then I have, is this in the form I want it in? No. What am I going to move? Plus 9. Okay, so I'm going to get 2x squared minus 12x. And then since there's a 2 there, I'm going to not put my plus blank in there yet. That's equal to 80. Right? If I add 9 to both sides. And then my next step is to divide everything out, right? You divide through by a. So when I do that, I'm left with x squared minus what? 6x. And then I'm going to go ahead and put plus blank equals, I got to divide 80 by 2. That gives me 40 plus blank. Everybody okay with that? I'll take that as a yes. So what do I put here in this blank? 9. Good. Half of negative 6 is negative 3. I square it. I get a positive 9. That makes a positive 9 here. So then the left-hand side is going to be x what? Minus 3. Good. Squared equals 49. Then I'm going to take the square root of both sides. And that's going to leave me with x minus 3 equals plus or minus 7. So I will get x minus 3 equals 7, and x minus 3 equals negative 7. So that means that x is equal to, let's see, I would add, so I would have a negative 4 and 10. Do I agree with that? What questions do you have? All right. I'm going to give you a minute. I want you to try 23. After you move that 70 over, what do you want to do? Divide by 4, yeah. And if you need to, let me just back this up. Like I divided by 2 and did this all in one step. If you need to make them separate steps so that you don't mess anything up, that is totally fine. Totally fine. Okay, good. You're good. No, you're fine. Do we have a question? Are you sure? Well, that could be a problem. That's more of a statement, but yeah, I gotcha. I have issues with that too. Do we agree so far? All right, 64 is what we're going to be adding there. Okay. Those are the two numbers I got. I keep looking over it here because I did it differently on my paper. I don't know why. But. Thank you. If we don't agree, see if we can figure out where you fell off the wagon, and hopefully the bus. I don't know, whatever we're on. Figure out where the bus ran over you, and see if we can. Hopefully, it's something simple, but that's more frustrating because the simple mistakes, like I didn't add right or something, that that's just human nature. But do we all understand the process? Are we all good on that? Yes. Okay. So then let's do 24. We'll just do the last two together then so that we can practice some and then you can have time to work. All right, so on this one, what do I need to move? Good, I need to move the 16x. So x squared minus 16x equals a negative 65. Okay. Oh, I guess, well, that's okay. I forgot to put my spaces in there, so I'll just do it here. X squared minus 16x plus blank equals negative 65 plus blank. All right, so what goes in the blank? 64. I take half, I get negative 8, then I square it, and it is 64, yes. Okay. So then this left side is going to become x minus 8 squared, right? And that's equal to negative 1. Then I'm going to take the square root of both sides. Left side becomes x minus 8. Right-hand side is plus or minus what? I. Very good. And then because I have a plus or minus situation over here that's not a whole number or not a number, well, it is a number, but it's not a rational number or a real number, then I can just say x is equal to, and then 8, because I'm going to add that over there, and then it is plus or minus I, because I can't simplify it anymore. You can put one I if you want now. That's not usually how you will see it, but it is definitely not wrong. But then again, saying that, when you type it into things like Delta Math or whatever your digital platform might be next semester, maybe it'll take it, maybe it won't. I don't know the answer to that one. Are we all good? All right, so when I look at 25, what do I need to move? 88 and 10x, exactly. Like, technically, I guess I could move the x squared, and then they'd both be on the same side, but I want that to stay positive. So instead, I'm going to have x squared minus 10x, because I'm subtracting that over there. Then I'm going to put plus blank equals. Then when I move, and when move, it means I have to move legally. That would make that a negative 88 plus blank. So don't make ridiculous mistakes like not changing the signs and things like that. So what goes in the blank? 25. Very good. So on the left-hand side, I end up with x minus 5 squared equals negative what? 63. Okay. Then I'm going to take the square root of both sides. And that gives me x minus 5 equals, is 63 a perfect square? No, 64 is, but not a 63. So plus or minus the square root of negative 63. Okay, so we know the negative is going to give us what on our answer? An I. And then that square root of 63, when you go over here, see if we can reduce that any. Well, it's not an even number, so can't divide by 2. Can I divide this by 3? Yes. So this would be 3, which is a prime number, times what? 21. And then factors of 21 are 7 and 3. Sorry, I wrote the 3 first because it was just what I was already writing. But yeah, 7 and 3. So then I can come back over here and say that x minus 5 equals plus or minus, I've got 2 3's. So that comes out as a 3. Now, the 7 is going to stay under the square root. I could write 3 square root of 7 times I, but it is best practice to leave the square root as the very last thing. So there's not a question about why the I is under the square root, like whether or not it is. So it's really 3 times I times the square root of what's left over, which is 7. Like that's more how you're going to see it. But if you get a little crazy with your square roots and you can't tell if the I is underneath it or not, that's when that's a problem. So then my final answer, x equals 5 plus or minus 3i times the square root of 7. And I could have kind of done that on the last step, but that's up to you. I just didn't want to lose anybody. What questions do we have? Are we good? Okay. So we still have quadratic formula to do. We're going to do that tomorrow. Because I thought I'm going to stop. I'm going to give you some time to work and then move on. So it should be in Canvas. You should be able to see everything and everything work nicely.